Welcome to Algorithm video series. Today let's write a Python program to solve this problem. Here is the problem statement. Given a sorted list and a target value, find the index of the first element that is greater than or equal to the target. So here input is a sorted list and a target value. Output is index of the first element that is greater than or equal to the target. For an example, here we have a sorted list and target is 40. Then we'll get output as index 4. Next, let's understand this problem in depth. Here we need to find the first position where the target value can be placed without disturbing the sorted order. So in the sorted list, we need to ignore all numbers smaller than the target and we need to stop at the first number that is equal to or greater than the target. Alright, let me explain this with an example. Start searching in the list. Ignore all numbers smaller than the target. Stop when you reach target or first element greater than the target, and the position where you stop is the lower bound. For example, if target is 40, start searching in the list. Ignore all numbers smaller than 40, that is 10, 20, 30. When we reach 40, you need to stop because it is equal to the target, and the position where you stop is the lower bound, that is index 3 here. And if target is 35, we need to ignore all numbers smaller than 35. And next, when we reach 40, it is greater than 35, that is the target value. So we need to stop there and that position is lower bound. Okay, let's understand this lower bound problem in simple words. Here we have a sorted list, right? If target is 35, then we need to find the position for this 35. If I want to place 35 in this sorted list, where I can place it, we need to find that position. Here we know it is a sorted list and here numbers are sorted in ascending order. So we need to place 35 after 30, right? And before 40. So we'll get the list like this. Here, if we place target 35 in this list, then we need to place that in the index 3. That's what we need to find here. We need to find the first position where target value can be placed without disturbing the sorting order. So here, when target is 35, the lower bound index is 3. Now what if target is already present? For example, if I'll take target as 30, then what is the output? Here, we need to find the first occurrence of the target. We'll place 30 here in the index 2. If I want to place target 30 in this list, I'll place it in the index 2. Before this 30. Here we are finding the position to place the target element without disturbing the sorting order. Okay, so to do this, we'll use binary search algorithm. But normal binary search algorithm doesn't work here. We need to modify that. So what we need to do is, first we need to start by looking at the entire list. Take the entire list. Find the middle element of the list. If the middle element is smaller than the target, ignore left half and continue searching the right half. And if middle value is greater than or equal to the target, keep this position as possible answer and continue searching the left half. This process continues until there is only one possible position left, and that position is returned as lower bound, which is the index of the first number greater than or equal to target. Let's take examples. Okay, if target is 30 and this is a list, we want to find where we can place this 30 in this sorted list. Here output is in the 4th index, right? Here we can see 10, 20, 20, 20. These are all smaller number. And here 30 is equal to 30. This is the first position where we can place our target. So output is index 4. In the lower bound, if target is already present in the given sorted list, we'll search for the first occurrence, okay? Okay, next let's apply modified binary search algorithm and see how this algorithm works to find lower bound index. Okay, so here we have list, target is 30. Initially low will point to the first index, and in normal binary search, high will point to last value. But here high will point to length of list. That is, here we'll take low equal to 0, high as length of list, here 8. In normal binary search, we'll take high as length of list minus 1. That is the last index of the list. But here we need to take high is equal to length of list. Why? Because here we are finding the position to place the target element in the sorted list. That position can be at the beginning, between elements, or after the last element. For example, if target is 80 here, so we need to place 80 in the last index after this 50, because 80 is greater than all other elements here. So we need to place that at last. So to place that, we need this position, right? So that's why here we need to take high as length of list. Okay, next we need to find the middle element. Here low plus high truncated division 2 to find the middle. 0 plus 8 truncated division 2, so we'll get this as middle. Then compare this middle element with the target element. Here middle element is equal to target element. If the middle value is greater than or equal to the target, then we need to keep that position as possible answer and we need to continue search in the left half. Here it is equal, so we need to continue search in the left half and we need to take this position as possible answer. That's why we need to take high equal to mid. So now this is a search area. Now again find mid. 0 plus 4 truncated division 2, so we'll get this as middle element. Compare middle element with the target element. 20 is equal to 30. 20 is less than target here. When 20 is less than target, then we need to ignore left half. We need to search in the right half. So here low becomes this one, right? Low points to this one now, mid plus 1. So now this is a search area. So find the middle element. Here we'll get this as middle element. 3 plus 4 truncated division 2, so we'll get 3. Then compare this element with the target. 20 is equal to 30. No, it is not. 20 is not equal to 30. Actually 20 is less than 30. So we need to take low equal to mid plus 1. So now low will point to here. Now actually in this search area we have only one element, that is our possible answer. Here in the modified binary search, when low is equal to high, we need to stop the search. And here this is our possible answer. So here you can written low. Low will contain our possible answer. That is output is 4th index. We can place target 30 in this 4th index without disturbing the sorting order. Let's take another example. Let's take 35. Here we can see 35 is not present in this list. So if you want to place 35, where will you place that? Here, right, in the index 6. So we'll get list as 10, 20, 20, 20, 30, 30, 35, 40, 50. So we need to get output as 6. Next, let's use modified binary search algorithm on this example and we'll see whether we'll get right answer or not. So initially, low will point to this, high will point to 8, length of list here. Then target is 35. Find the middle element. Low plus high truncated division 2, so we'll get 4. Compare 30 and 35. Here target is greater than middle element. So we need to ignore the left half and continue search in the right half. So to search in the right half, I need to take low as mid plus 1. Now this is our search area. Find the middle element. 5 plus 8, that is 13. 13 truncated division 2, so we'll get this as middle element. Compare 40 and 35. Middle element is greater than target here. So when middle element is greater than or equal to target, we need to take this as the possible answer and we need to search in the left half, right? We need to take high equal to mid. Now this is our high. 30 and 40. Find the middle element. 5 plus 6 truncated division 2, so we'll get 5. This as the middle element. Compare 30 and 35. Middle element is smaller. When middle element is smaller, we need to search in the right half, right? So here low equal to mid plus 1. So now here you can see low is equal to high. Only one element is present here. So this is the possible answer. Written low now. Low value is 6. That is our answer. At 6th position, 6th index, you can place 35. Okay. Here in the normal binary search, we'll find the target value in the sorted list. Find the first position where value is greater than or equal to target. Written -1 if target doesn't exist. Works even if target is not present. If target is not present, then also we'll get an index. If duplicates present, returns any index of the target. Here find first occurrence in case of duplicates. Here we'll take low equal to 0, high equal to length of list -1. Here low equal to 0, high equal to length of list, because here we'll search for a target element. Here we are searching for the position. This is the stopping condition. When mid element is equal to target or low becomes greater than high, we need to stop normal binary search. But here when low becomes equal to high, we need to stop. Okay, so this is the difference between normal binary search and modified binary search. Next, let's write the program. Here input is a sorted list as well as a target element. So here we can see the code for that. Here I'll assume that you're already familiar with how binary search algorithm works. So I won't explain the terms related to binary search algorithm in more detail. So next, here let's define the function for modified binary search. I'll take lower bound. Here a list and target, just like we do in the normal binary search. Low equal to 0, 2 pointers, high equal to length of list. Then in the binary search, we'll use while loop and we'll take while low is less than or equal to high. But here we need to stop when low becomes equal to high. So when low is less than high, we'll perform these operations. When low becomes equal to high, we need to stop. Here find the middle, low plus high truncated division 2. Then we need to compare middle element. So numbers made is less than target. Look, if target is greater than the middle element, then we need to search in the right side, right? We need to take low equal to mid plus 1. This is how we will search in the binary search algorithm also, right? If target is greater than the middle element, we'll search in the right half. Else, if middle element is equal to target element or target is smaller than the middle element, then we need to search in the left half. Also, what we need to do is, we need to take the middle index as one of the possible answer. That's why here we need to take high is equal to mid. In the normal binary search, we'll take high is equal to mid minus 1. But here we need to include this target is equal to middle element condition also here in this else block. That's why we need to take high equal to mid. We need to take that index as one of the possible answer. Okay, so we need to take high equal to mid. Then here after while loop, when low becomes equal to high, we need to return low. Here you can return high also, because this condition will stop when low is equal to high. So both low and high point to the same index. Here I'll return low. Now we are done. Here we need to call this function and store that result, because this function will return a result, right? Next, print the result, save and execute. Number of elements in the list, let's enter 5. Then I'll enter 35. We can place this 35 after this 30, right? Before 40. So index is 0, 1, 2, 3. We need to get index as 3. Yes. I'll enter 40. So we'll get lower bound index as 3. With diagram, you can understand lower bound like this. Okay, so that's it for now, guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.